So, good morning to our attendees in the US, good afternoon to the people from Europe, and good evening even, and welcome to the brave people in Australia who are still awake to attend our System Integrators webinar entitled Three Powerful Integrations of Space-Time Analytics to Win Big Data Projects. First of all, I will introduce to you our speakers. So we have Bart Adams. Bart is one of the two founders and the CTO of XYZ.ai. Bart also has 20 years of experience in building integrated products. And then there is myself. My name is Nick de Beer. I'm the head of business development at XYZ, and I will also be the moderator today. So before going through the agenda, I just want to start with a few points to mention. So for some interactivity, we will ask you some questions during the webinar, and it would be great, of course, if everybody could answer those. If you have any thoughts or questions during the webinar, then you can always ask them via the Q&A or chat. We will try, obviously, to reply to as much as possible at the end of the webinar, and otherwise we will definitely get back to you via email. The webinar will also be recorded, and the recording will be shared once available after the event. The webinar should take more or less 45 minutes, and then at the end, we will, of course, have some time for Q&A. So for now, please mute yourself if you haven't already, and enjoy. So I'll go to the agenda right now. So we actually divided this webinar in three major topics. Topic one is, of course, we will explain what the importance is of spatial-temporal data, and that will be done by my colleague Bart. Second topic of today is we saw that there are a number of problems when using traditional technology stack. And we also want to explain today how you can overcome those. And then the third part of today, we also worked out three integration examples, which we have actually today with existing customers and would like to share with you as an example. So now I will give the word to my colleague Bart, who will tackle the first point and explain to you what the importance of spatial-temporal data is.
Okay. Thank you, Nick, and thank you all for joining this exciting webinar. So first of all, spatial-temporal data is data that we see being available in increasingly larger numbers over time. So what is spatial-temporal data? Spatial-temporal data is basically data that has both a spatial, where, and a temporal component, when. And we identified 4 drivers that we saw over the last decades that made that this data becomes so much available now. And it becomes an increasing available source for intelligence for government projects, but also for large enterprise projects. The first, of course, is digitalization. We've seen that happen over the past decade. In this example, you see almost 10 years of accident data, US accident data, that is now available in databases for use by governments, by city analysts, for example, to improve road safety. And that's only available because we're living in a digital world. Second technology is sensor technology. In the example that you see here, this is open sensor data, air quality sensor data throughout Europe and the rest of the world, measuring particle matter every second, every 5 seconds throughout the day. Thanks to this technology, there's spatial-temporal data that can be used to analyze the impact, for example, of traffic or industries. Third driver is connectivity. We're all connected all the time with our cell phone, but we're also increasingly more connected with our cars and other vehicles. And this connectivity makes that data from those vehicles is becoming available. And today we will show you connected vehicle data, which is data gathered from vehicles driving on our roads. And then a fourth driver, an increasingly important driver, is everything that's happening in space. There's so many more satellites being launched, and those satellites, they don't only sense the Earth by taking pictures or by measuring reflection, but they also listen to the Earth. For example, they pick up messages from vessels also when they're in the vast oceans. And that makes that, as you can see in the picture, analysts can use this data to get an understanding of the global world trade on our waters. And the result of all this technology is that there's so much data. And just to give you a sense of how much data there are some predictions here, for example, by Fast Company, that by 2030, there will be over 29 billion sensors or connected IoT devices generating data throughout the world. To make the jump to mobility and traffic, and this is a prediction by McKinsey, by the same year, 2030, it is expected that almost 95% of new sold vehicles will be a connected vehicle. And by that time, there will be over 2 billion vehicles on the road. So think about the amount of spatial temporal data that this is generating. To give you a more actual number, one of our customers, which is the city and state of Hamburg in Germany, is using databases or data sets that are over 30 billion records large. And that is floating vehicle data for 1 year, and they use multiple years of data. So we're really getting into the hundreds of billions or trillions of data points. So this is a lot of geospatial data and also geotemporal data. And what is happening now, we see that over the past decades, governments and enterprises, they have been educated by the data providers, by different seminars and webinars, and they are now putting out tenders that include a requirement to purchase this data and to make this data actionable. And this is an example of a major tender that came out this summer in one of the major EU countries, and it's around floating vehicle data. And you see the budgets are really large, like 2 million for the data, almost 1 million for an analytics platform, and then using that platform, a couple million of man hours to do traffic studies using the data and the platform. So this is a big opportunity for system integrators, for consultancy companies to get into those new big data projects. That being said, the big question today is, how do you go about and make this big data actionable? If you have to provide an analyst in the city of Hamburg with the capability to look at 30 billion records, how do you do that in a competitive way without burning all your resources on cloud compute, for example? And that's what this webinar will be about. But first, Nick, I think we have our first poll question. You're still mute, Nick.
So thank you very much, Bert, for this explanation. So indeed, first poll question of today, have you worked on big spatial-temporal data projects? And the answers are A, yes, we have, B, not yet, but we plan to, or C, no, and we are not planning to. So I will wait for a couple more seconds so that everybody can reply to the poll. And then obviously we will also share the results. So here is the result of poll question 1. And so you see that so half of all of the attendees answers yes, we have, and almost all the rest says not yet, but we plan to. So that for sure, for us, is already a good indication that we have the right people in this webinar today. So thank you for replying to this first poll question. We will now go to the second topic of today, which is overcoming the problems of traditional technology stacks, and I will explain to you. So we have defined 3 problems, and here is problem 1. Problem 1 is about the fact that classical tools don't really scale with the amount of data that we see today. We encounter a lot of projects where the data grows and grows and grows over time, for the simple reason that the time range expands, or the region expands, or you want to combine multiple data sources together. And all of that was not there before, or in the beginning. This was not happening. And so the tools that were available 10, 15 years ago, they were actually not really built to work with these amounts of data. If I go to problem 2, it's very hard typically to answer questions that relate to where and when. There are a lot of tools in the market that are very good with the where, so with the location, the X, Y, and Z. And then there are a lot of tools that are very good with the when, the T. And that is also where the name XYZT, by the way, comes from. We have really built a platform with the idea in mind from the start that we should be able to answer questions that relate to where and when. And to give you a very simple example, it's good to know that, for example, there is congestion on a highway, but ideally you also want to know when in time that congestion happens on the highway. And then if I go to problem 3, it's more about the development. It's about the problems that system integrators often encounter. If you need to build yourself, it will take you down a long and costly path. You see, we often use this example with this arrow, where we map out all the different steps from having a data lake to sharing insights out of that data lake. And here we really want to explain that there is a real problem in building it yourself. So it will cost a lot of money and it will take a lot of time, and that is typically things that nobody really has. So one solution, and that obviously is the XYZT.ai platform. So what is XYZT.ai? It's a scalable visual analytics platform for spatial-temporal data. So as Bart already mentioned before, big amounts of data, and the data always has a spatial and or a temporal component. So the view that you see here is our visual analytics view. You see it has a lot of performance in scaling for billions of records. You can bring your own data and fuse multiple data sources. At the same time, time is handled, as I mentioned before, as a core dimension, and it should be as easy as a BI tool to use. So I will now go over the different solutions we have for the different problems I made or I stated. So value 1 is the scalability. So you see that XYZT is really built for big data, and we can go to 1 billion plus records. And if you think about it, if I refer back to what Bart explained about, or the statement that Bart made in the beginning of this webinar, that the city of Hamburg, for example, has 30 billion points a year, meaning roughly 2 billion a month. If you would put that in the XYZT platform, there wouldn't be a problem at all. If you would go to open source or traditional GIS or BI tools, then your time frame would be limited from a month of data to a couple of minutes or even a couple of seconds of data, which obviously doesn't give you the same insights when you are looking at a month of data. Value 2, when people ask us often, where are you? Because you do a lot of GIS, but we also see time series, and it looks a bit like a BI tool. We indeed like to say that we are on the intersection between the 3 of those. So we have a lot of GIS components in our platform. It's a visual tool. We take time into account as a core dimension. So we also support time series analysis. And at the same time, we really aim to have a very easy to use UI so that it becomes so easy to use as a real BI tool. That brings me to the third and the last value. about time and winning money. So what we really try to explain here is that by using XYZ.ai, you shorten the circle for the go-to-market, meaning you will win a lot of time and also a lot of money. So you will go faster to market with a new solution. It will go quicker with an XYZ.ai integration. Before giving the word back to Bart, I would like to summarize this topic. So what you need to really keep in mind when thinking about XYZ.ai is one, we focus on spatial and temporal, so on where and when. You can easily, in a secured way, bring your own data. So we have open API standards, but Bart will still explain a bit more about that later in our webinar. We can really be future-proof when it comes to the amount of data that you will put into the platform. So you maybe don't necessarily have a lot of data today, but for sure you will have in future. And we are prepared. Our architecture is prepared to work with that data. And then, to me, the most important point, especially when looking at system integrators, is you can accelerate monetization. So we have different components built in our platform that make it very easy to collaborate within or with external parties to share and embed different insights and dashboards with customers. And that, to me, seems a very important benefit for system integrators, but I think that Bart will also explain later on. So I will now hand back over to Bart for the third topic of today. He will explain to us 3 integration examples we have from our customers.
Okay, thank you, Nick. So for me, this is the very exciting part where I can finally show some code snippets. So bear with me. If you're not technical, it's not gonna be too much. So I'm gonna talk about 3 different integrations. The first one is related to what I talked about, the floating vehicle data. We see that being picked up a lot with states and governments. And I want to show you how a customer of us, or basically a partner of us, Inrix, is making this data available through our platform to, for example, Autobahn, which is the main road authority in Germany, or the city of Hamburg or Aachen or other cities in Germany. And I'm going to show you that you can do what they do in only 5 API calls. So not much code to be shown there. Second integration example that I'm going to show is a port situational dashboard. So for those of you who are not from the maritime domain, you know that most of the goods that we buy and people sell, they're transported by sea. And during Corona, we all encountered what the impact is of a shutdown or slowdown. And so having visibility on your port is essential these days to make sure that you have good and fluent operations. And I'm going to show you how we built under a week a port situational dashboard for every major port in the US. And this is about 100 ports. So that's a big ROI. And I'm going to show you how we leverage the XYZ platform. And then finally, the third example is a bit different. It's not a cloud example. It's not a SaaS, software as a service example, but it's an on-premise example from a security context. And there, I'm going to explain you how you can deploy the XYZ components as building blocks for a GeoInt, which is geointelligence application that runs on board of patrol vessels. And the really nice thing is when we mapped out the architecture and made the design, we saw that we didn't have to update any existing infrastructure, which is a huge benefit to that system integrator. But before going into detail, let's take a short break with a poll. Nick?
Yes, thank you, Bart. So second question for today, what does your typical integration project looks like? A, it's all in the cloud. We love serverless. B, custom architecture with on-prem microservices, C, all custom development with open source, or D, other? We will again give you a couple of seconds to reply to the question.
And you can answer multiple options on this one.
And then the result should be there soon. Voila. So here, bit tricky. So we have almost half who says in the cloud, which is our main purpose. And then also the other half says they use a custom architecture with an on-prem microservices. So I think, Bart, it's actually the perfect fit for you, as you will explain on-prem solution, and you will explain cloud solutions as well. So go ahead.
All right, thank you. And I see we have about 20% of attendees to convert still, Nick. So let's go into the 3 powerful integration examples. But first, before doing that, I want to give you a very high-level architecture overview of how typically our platform is being used in a project. So think of having some data somewhere, whether it's a database, a data lake, whatever you have. And you want to make that data actionable. And typically that happens by a continuous process, maybe a real-time process where you have data coming in every second, every minute, or maybe it's by batch jobs that you run every night and so on. So basically we provide an API, which is an HTTP API, a REST API, that allows you to automate all these things. So you can create data sets, upload data, create dashboards, and so on. And this is what I will show today mostly. Then in the middle, we have our platform, which consists of microservices. There's different of them. There's some that accept data, process data. There are microservices that accept queries on the data. And we have a very scalable spatial-temporal database implementation that is really our own, that we built after almost 20 years of experience, Nick, making sure that all those queries can be performed as efficiently as possible. And then on the right side, on the user-facing side, there's a front end, which you can just use as is, which we call direct analytics, or you can embed it in your own application and then start using our components from there. And of course, if you use it direct, and I'll give a really nice example about that, you can also build application dashboards that you then share with your customers or your stakeholders. And that's what I show here on the far right. So what is this API? So if you're familiar with basically browsing the internet, you're familiar with going to an HTTP website. And basically, a web API is like that. You have endpoints that are basically URLs that you can visit with certain parameters and that give you a result. And the result can be a query, or it can be the fact that you uploaded a file with success. We chose from the start to follow a standardized way to provide the API. And the standardized way that is used a lot is called Open API. And as you can see on the right side, you can see our API documentation platform, and you can see at the top here that you can just download our Open API specification. It comes as a JSON file, and that makes it really useful for tooling. Basically, the whole API, all the different actions that you can perform on the XYZT platform are documented, specified in that JSON file. And JSON is just a text file that computers can read very efficiently to understand what is available. There's tutorials on the platform on how to use this specification, but in essence, you can generate an SDK from that specification. An SDK is a software development kit that is basically how you code against the API. And you can do that in different languages. The most popular that we see are Python, of course, but also you can use TypeScript, which is very nice to use, or you can use Java, C++, C, Rust, whatever language you prefer. And that's really nice because this way we can expose our API to all our customers in their preferred language. And it takes us very little effort to maintain this. So we only have to maintain basically the Open API specification. And so these SDKs, they call the XYZT platform behind the scenes. The user using the SDK doesn't even see that this is happening. There are basically those web calls to the XYZT platform. So I'm going to give you 3 examples now. And the first one is a very important one for us. It's really driving a lot of innovation with cities and state and road authorities. And this is about floating vehicle data. And to give you a better understanding of what floating vehicle data is, I'll just show it in the platform to you. So I have the platform open here, and this is a live demo. It's one of the sample projects in the platform, and it covers basically the region of one of our joint customers with Inrix, the city of Hamburg. And you see a density map on the center of the screen. You see trend lines at the bottom, and you see layer panel to basically have multiple layers of data, and you see a few of the properties in the data. And if I would zoom in on the map, you would see every little square is at least one floating vehicle data point. So it's a GPS coordinate with a speed property, with a heading property, and so on. And you see there's a lot of data. And as you can also see, I can freely navigate around. I can change visualizations. For example, if I'm interested in looking at the speed profile, I can zoom in on an area and I can immediately see on the timeline how busy it is, or I can immediately see here what the speed distribution is in this area. And then, of course, I can do all kinds of filtering. And for that, I have to move this little zoom widget here. I can do all types of filtering, for example, analyzing all the traffic that flows in this direction, entering the city of Hamburg, where does it go, and so on and so forth. And the platform provides all types of spatial temporal analytics. Now, what is really important to analysts in this domain is that they have accurate, up-to-date data. Typically, you don't want to work on too old data. You want to work on the data that is fresh to see what is happening in real time. And we have a number of joint customers with Inrix, City of Hamburg, Aachen, Autobahn in Germany. And so we needed an automated way to basically get this data to those customers. And that's what I will show in this integration example. So this is the architecture. On the one hand, you have the connected vehicles. It's a continuous IoT stream. Typically, data is collected by different companies. And at some point, all the data comes together in the Inrix data cloud. What we then did with them is we set up cron jobs that run daily, every night, and they pick the latest data from that data cloud for the specific regions where there are customers. And then that data is basically pushed to xyzt.ai. It's pushed to different tenants. So there's clear separation between different tenants. And every tenant can then start using the XYZT platform with the data. So in the morning when they log in, they get to see a fresh update of data. And typically it's multiple billions of data points every night that are entering the XYZT platform. So a little peek behind the scenes. I don't want to spend too much time, but we can go into detail on a separate call. Basically what is happening, there are cron jobs, and cron jobs are jobs that are scheduled at a regular pace. In this case, every night. The first thing is, and I try to simplify here with basically the console command. There is data fetched from an S3 bucket, which is a big data storage bucket on the Amazon cloud. It's stored locally for processing. And then the first API call is to call a create dataset on the XYZT platform. And you see how simple it is. So you just call create dataset. There's a few parameters that you have to supply. The next thing to do is to define what the schema of that dataset is. So what are the properties in the data? And one way to do it is to predefine it in a small CSV file, basically telling the platform the first column is the longitude, the second column is the latitude. You can also do that for metadata, which is constant data, data that doesn't change over time. For example, you can say that a certain trip of GPS points belongs to a truck that you can define in the metadata. Once you have the schema, you can upload the data, and that's it. 2 more API calls. And this is what happens every night on multiple cron jobs for all the different customers. And as a result, customers get access to immediate analytics on the latest data. So what is the ROI? There's, of course, a big ROI for INRIX because they can sell their data more easily. But also for the end user, there's a huge ROI from starting using this data. If you think about the classical way to do traffic analytics is to look at basically traffic counters on the road, to look at CCTV cameras to do the counting, and basically to have that infrastructure in place. The estimate is that about 50 miles of roads to cover, it costs you about 1 million USD. So that's a huge investment that you have to make if you want to cover every single road in a state or a country. And that is avoided. Of course, there's a cost to the data, but it's really much smaller than having to put infrastructure on all the roads. And with our platform, we enable those customers to really easily look at data. The second example I want to show is a port situational dashboard that we built for every port in the US. And the developers built it in under a week, so just 1 man week of time to build it. And I'm quickly going to show you what it is by logging in to a different account. So I'm logging into the port visibility account where all the projects live. So every little card that you see is a project, and every project consists of multiple data sources. There's data about anchorage zones, there's data about the vessels, the positioning of the vessels, and so on. And so what does the dashboard provide? It provides visibility on what is happening in the port, what was the trend over the last week or the last 2 weeks, and how is it changing? For example, you can look at the actual situation. How many vessels are there? How many vessels are moored, anchored? How many cargo tankers, and so on. You can look at the 2-week summary. Is there an increase? Is there a decrease? So for example, here you see 2 trend lines, one 2 weeks ago, one of the past week. And then you see the change, the overall change. So there's about 4% less traffic in the Long Beach port near Los Angeles. So the dashboard shows dwell times, all kinds of statistics that are live updated when new data enters into the platform. And the analysts, they can click through if they really want to investigate what is going on. They can click through, they can provide additional filters. For example, okay, I'm really interested in what is happening in this anchorage zone. They can see, okay, there's been over this period so many ships and these are the MMSIs and so on. So it gives you a lot of power as a port authority to get insights. So we built it in a week. And basically, we used the same approach as with the floating vehicle data. The developers chose TypeScript in this case, so you have to make a jump from Java in the previous one to TypeScript in this one, but basically it follows the same logic. First of all, we know what ports there are, so we loop over all the ports. We create a project with a port name and so on, and we create all the different data sets, so very similar API calls. What I want to focus on now is really on how do we make the dashboard, because it's not a manual process. It's entirely scripted and programmed. And I just want to highlight one widget on the dashboard, which is the widget that I looked at with the 2 weeks that are compared, which shows the overall trend in traffic over time in the port area. Basically, that widget looks like this. You create it using an API call again, create trend analytics widget, and you provide some information. First information is how wide does the widget have to be, what's the height, what's the title, what's the type of the widget. And then you also provide which data to use. For example, you provide the ID of the data set. And that's all there is. Of course, to populate a dashboard like this with, I think, about 50, 60 widgets, It's a bit of code, but once you have the hang of it, it's quite easy to implement it. So what's the ROI? I did a quick back of the envelope calculation here. Took us about 1 week. So average cost is about $10,000 worldwide. In Belgium, it would be a bit higher, so around 2.5, 3,000 US dollars. A license, depending on the amount of data, can start from 50,000 a year. But the good thing is you can use that same license for hundreds or maybe even thousands of ports worldwide if you want. And ports are willing to pay in the order of 10 to 30 or sometimes even more, depending on the size of the port. So you can see how you can leverage the platform to multiply this ROI investment. I see we're running close to the end of the webinar. I want to give one more small example. Well, it's a big example for us, but it's I don't want to spend too much time on it. It's an example from the security context where the platform can be deployed on board of patrol vessels. And in the security context, you have something like that is called geo-intelligence. It's basically applications that are used to gather intelligence on what is happening in the world. And in this case, the system integrator asked us, can your platform be deployed on board of patrol vessels so that analysts on the vessel can use real-time data in combination with historic data to get a better sense of context, to better understand if they see an airplane or they see a vessel, what's the context around that vessel? And of course, we wrote the platform first as a cloud platform, but we also make it available now as an on-prem. It's written in Java in the backend, TypeScript in the front end, so it's very easy to deploy. So from an architectural point of view, this is what it looks like. There was an existing onboard C2 system. C2 stands for command and control. And that was basically used for real-time data. So there is a track feed, and actually there were 3 track feeds, an ADS-B feed, which is aircraft, AIS feed, which is vessels, and a radar feed as well. The processing service is a microservice that we give as a Docker. It accepts the data, structures the data, stores it in file-based storage like we do in the cloud. There's also some database, MySQL database, or a Postgres database that you can use to store the project information and so on. There's a second service that is running that provides basically the web app. So it's a simple service that just provides the TypeScript, JavaScript code. And that is the application that the analyst can use. The application itself, it uses a third service, which is the visualization and analytics service, which does all the heavy lifting when querying and visualizing the data. And it runs again in a Docker on the existing hardware. We made it so that we can run it on very low-end hardware, which is typically the case in security context. So in this case, we could run it in 60 gigabytes of RAM with 2 cores for those different services. And then finally, of course, the XYZT platform also accepts OGC services, so we could combine it with ECDIS charts, which are basically navigational charts used to get a view on the maritime environment, but they also play an importance in providing context when analyzing. So here also, if you would have to build this from scratch, it's a $1 million project. In this case, we could keep the investment cost very low compared to that million. And yeah, the throughput time to glue things together, to build the connectors, to accept the data and so on, was only a couple months' time. So I see we're running almost out of time. One of the questions I typically get as a CTO when I join Nick on sales meetings is, okay, how does it compare to building ourselves? What's the cost? How much does XYZT cost? And it, of course, depends on every case. Every case is different, as you know, Nick. So I try to give an example, a project where if you would start from scratch, and it takes you about 18 months to get to MVP, which is very realistic in a software project, and you have 2 developers. It will cost you around, on average worldwide, depending on the region you are, around $360,000 or euros. Then the maintenance, you have to count 20%, 30% of the project cost. And then hosting and storing data in the cloud, for example, would be 24K a year, a typical cost. So for a typical average size project, around €500,000. With XYZT, you can shorten the time. So integration costs can be a week, a month, a couple months. So in the order of a couple 10K. And the license cost, it all depends on what you need, what capabilities you need, but on average, I would say around 50K. So you see the ROI is around 7 times just from not building yourself. So this is what I wanted to present today. We are really in the business to help integrators be successful for big data projects. And Nick, I think you can summarize the takeaways of the webinar.
Yes, thank you very much, Bart, for this explanation. So we have 3 major key takeaways that we want to still share with you. So the first one is that what we see overall is that governments and large enterprises, they are really taking up these big data opportunities. So in our opinion, this creates opportunities for us, but also creates opportunities for the system integrators and even creates opportunities for their customers. Second takeaway, XYZT is really designed to integrate in any architecture and through an easy API. And I think that is also something that is unseen in the business. And then the third takeaway for today, I already mentioned it before, but it's a very important one. You can go to market quicker within the budget and with less risk. So now, before going to the Q&A, we have a last poll question for you. And it's actually the most important one for us. Do you have any projects in the pipeline today? So answers, yes, working on one as we speak. B, no, but coming up in the next 6 months. And C, no, but please keep me informed. I will give a couple more extra seconds to reply to the question, and then we can go to the Q&A before closing off this webinar. We have received some questions, so I will go through them. If your question, if we don't manage to reply to all the questions within time, because I see that in 3 minutes, actually, it's over, then we will definitely get back to you via email. So Bart, I think there is one question here, and I think you be best to answer. Somebody asks us, I often work in a closed environment, so is there an on-premise version available? You already explained that there is, but can you maybe iterate a bit more on how it would work or how it should work?
Yes, yeah, of course. So indeed, we can provide the software. The software comes as a number of packages with, of course, installation and so on, manuals. But in essence, it's a microservices architecture, like I explained. So in essence, you have a number of Dockers that you can run that set up the microservices. You can choose the architecture of your compute nodes. You can run everything on a single machine, even on a laptop if you want. You can run everything on separate machines or on virtualized operating systems if you want, and you can do that on Linux, Windows, even Mac. We use as developers as well. And indeed, when you're in a closed environment and there's no outside connectivity, it's air-gapped, it can run as well. Of course, you will need to provide maybe some background layers through an OGC service that you also run in that disconnected environment to provide some background layers. But other than that, there's no constraints. So yeah, I would be happy to learn about the projects. There we can maybe do in a follow-up call, Nick.
Yes. Thank you very much. Then there is a second question, and I will maybe take that one. So, how does the collaboration model with Integrators work for XYZT? There, I would like to start by saying that XYZT, as a company, we try to be agile. So we don't really have one way of moving forward with an integrator. What we do see a lot is that integrators ask us about developer licenses, so that they have the full capability of the platform and can make mocks and do trials for their customers. And so that is a model that often works. And then there is a third question, and that will be probably the last one for today. Bart, it's for you again. How easy can I connect XYZT to Databricks or Snowflake?
It's a very, very relevant question. And yeah, we see a lot of organizations leveraging Databricks and Snowflake, and at some point it will be clear who the winner is. There's a couple options there. The first one is those environments, and Snowflake is a bit different than Databricks. They allow you to run your own Dockers inside the environment, so to have your analytics or your visualization close to the data. And that's also what we do in the cloud. We keep our Dockers and close to the storage, so to get the best performance. So that's one option. So then you basically don't make use of our cloud deployment, but you use your cloud deployment with our packages or our Dockers. So that's one option. Second option is that you don't use that option, but you leverage our SaaS cloud deployment. And then typically what we see is that people do is they generate those Python code and they basically communicate with our backend through the Python SDK or API, communicating with our platform. So that's a second option. But yeah, if there's a very concrete question or case, I would be happy to jump on a call to get into an architecture diagram and discussion.
Okay, thank you very much, Bart. That's all the questions for now. So if you still have questions, then don't hesitate, obviously, to reach out. So for now, I would like to say thank you to everyone who joined us today. Again, if you have questions, concerns, remarks, don't hesitate to reach out. We will, as mentioned before the webinar, send out an email shortly with the links to the recordings, with our contact details. And then to close off, thank you very much, Bart, for this very interesting webinar. And to all of you, have a nice rest of the day. Bye.
Thank you all. Bye-bye.
Bye.